We are discussing about the quadratic expressions and equations. So we start with the first topic, which is about solving quadratic equations. Following are the learning outcomes, and then alright. So this is the general form of a quadratic equation. So we have ax squared plus bx plus c equal to 0. Okay, so as you can see here, the highest degree for the x is 2. That is why we call it as a quadratic equation, because the highest degree for this equation is 2. And then we need to make sure that the a is not equal to 0. Why? Because we want to maintain the power of x. The highest power of x is equal to 2. Because if a equals to 0, then that means, okay, x squared becomes 0. So the highest power for x now is x to the power of 1. So it becomes a linear equation. So it's no longer a quadratic equation if a equal to 0. So we need to make sure that the value for the a not equal to 0. For the a, b, and c, we call all these three values as constants. Okay, as constants. Okay, in other words, we can say that a, b, and c are fixed. And then the x, okay, the x, which can be any real number, is what we call as variable. Alright, so a, b, c are constants, and x, which is a real number, is considered as variable. Okay, so how to solve a quadratic equation? So we have basically three methods to solve a quadratic equation. So we have factorization method, we have completing the square method, and we also have quadratic formula method. So we start one by one. We cover one by one. We start with the factorization method. Okay, consider the following example. Solve the following equation using factorization method. So we're given that x squared minus 7x plus 12 equal to 0. So we need to factorize this equation. Okay, we factorize this equation. Okay, we just simply, because we have x squared, so we have x and x. Alright, now we need to find what two numbers that can be multiplied together and come out with the value 12. Or in other words, what are the factors for the 12? Okay, we have 3 and 4, the potential. Okay, the potential factors for 12, we have 3 and 4. We also have a 12 and 1. We also have, what else? 6, okay, times 2. Okay, the following are the potential factors for 12. But then we need to find any factors that can give us negative 7. Negative 7 when we add together. So from among all these three candidates, so we have 3 and 4 as the best candidate to come out with value 7. So how to get value 7 and at the same time we get 12 as the product of these two numbers? So it's very easy. We just put negative as both numbers. Okay, because negative 3 times negative 4 is equal to 12, and negative 3 plus negative 4 is equal to negative 7. So we get both numbers. Okay, 12 and negative 7. So we have negative 3, also we have negative 4. Alright, so we combine together, so we come up with these two factors. We have x minus 3, x minus 4 equal to 0. Okay, so the equation becomes true or false if one of these two values equal to 0. That means this equation, okay, you can say is a times b equal to 0. So this equation becomes true when one of either a or b equal to 0. For example, 0 times b equal to 0. A times 0 equal to 0. Okay, that is why we have O at the middle. So we have x minus 3 equal to 0 or x minus 4 equal to 0. So now it's very easy for us to factor to solve for x. So we have x equal to 3 and we have x equal to 4. Okay, so if you represent the answer in the set form, so we have this curly parenthesis, okay, where the answers are actually x. Okay, because the question asks you to solve the equation, that means we need to solve for the variable x. So x, okay, are the values for the x are x equal to 3 or x equal to 4. So this is what we call a solution set. Okay, for the second one, we have another equation. We have 2x squared plus 5x plus 3 equal to 0. So now it's quite different with the previous one. Previously, we have the constant for the x, okay, which is a equal to 1. Now we have the constant for the a equal to 2. Okay, so how to do the factorization? All right, so in this case, we have 2x and x, and produce when we multiply it becomes 2x squared. Okay, so now how to get 3? Okay, 3. Okay, it's very easy. The factors for the 3 is 3 times 1. That is the only factor for 3. So we have 3 times 1. Okay. Okay, now so we multiply 2x times 1, we have 2x. We multiply x with 3, we have 3x. So we add together, come out with 5x. So we obtain 5x. And when we multiply 3 times 1 equal to 3. So we get the whole equation. Now we have the factors 2x plus 3, x plus 1 equal to 0. So just like the previous case, okay, so this equation becomes true when one of these two values equal to 0. That is why we use O at the middle. So we have 2x plus 3 equal to 0, x plus 1 equal to 0. So we solve for x. We have x equal to negative 3 over 2 or x equal to negative 1. So represent the answer in the set form. So have this curly parenthesis to enclose the answer. So we have value for the x equal to negative 3 over 2 or x equal to negative 1. Alright, now we move to the third one. Okay, so the equation for the third one, it's quite simpler compared to the previous two examples, because the value for the constant b equal to 0. So we have x squared minus 25 equal to 0. So to solve this equation, we just take 25 to the other side. So we have this equation, and then we eliminate the square by put square root at both sides. So we have x equal to square root of 25. So the answers are plus minus 5. So we have two possible values for x. So x either x equal to 5 or x equal to negative 5 as the answer. Okay, now we move to the second method, what we call as completing the square method. So we have 4 main steps in this method. So we start with the first step. So we need to make sure that the coefficient for the variable x squared equal to 1. Okay, we need to make sure the coefficient is equal to 1. That is the first step. The second step is we add both sides of the equation with b over 2 square. Okay, so that means we need, from the given equation, we need to identify which one is b. We divide by 2, then we put square. And we need to add this value at both sides of the equation. The third step is the left side is factorized into complete square. Later on, I'll show you what is the meaning of complete square. And the final step is we solve the equation by taking the square root for both sides. Okay, so let's see how to do the completing the square method. So given this equation, x squared plus 6x minus 3 equal to 0. So based on the first step, okay, we need to make sure the coefficient for the x equal to 1. So we done because the coefficient is already equal to 1. So we move to the second step. Okay, so next we need to put we take a negative 3 to the other side. Okay, so it becomes positive 3. So at this step, we identify that what is the value for the b. The b is equal to 6. Okay, so in the next step, we need to put 6 over 2 square. Okay, we need to add 6 over 2 square at both sides of this equation. So we put this one at the left side. We put this one at the right hand side. Okay, so we simplify the fraction. It becomes 3 square. Okay, so at the left hand side, we have x square. We also have positive or plus 3 square, which can be combined together, becomes the complete square x plus 3 square. Okay, becomes the complete square x plus 3 square. At the other side, at the right hand side, we can compute these two values, 3 plus 9, which is equal to 12. Okay, now the next step is to eliminate the square sign. How? By executing the next step, which is to put square root in both sides. So we put square root at the left side so we can eliminate this the square. We put square root at the right hand side so we have this radical. Okay, so we have x plus 3 equal to square root of 12. Okay, next. So how to solve this equation? So we know that, okay, the value for the this value can be positive or negative, can be plus or minus. So we divide to two sides. We have x plus 3 equal to positive 12 or x plus 3 equal to negative assert 12. Okay, so we solve for the unknown x, okay, because our interest is to know what is the value for the variable x. So we take 3 to the other side, so we compute, so come out with these two values. So we summarize the answer in the solution set form. So this is the final answer. Okay, so now we move to the second example, still about the completing the square method. So in this example, if you notice that the coefficient for the x square is not equal to 1. So that means we need to do something in order to make it equal to 1. So obviously, in order to make the coefficient for the x square equal to 1 is by multiplying, okay, multiplying each item in this equation, including at the right hand side. Actually, we multiply with half. Okay, we multiply with half because we want to eliminate this 2. Okay, we want to make it equal to 1. So we multiply with half and applicable to all items because we need to multiply half for the left hand side as well as the right hand side. So because at the right hand side we have 0, so it remains 0. Okay, so we multiply with half, so we have this simpler equation. So we have x squared minus 2x minus half, so we take half to the right hand side, so we have this equation. Okay, we have equal to positive half. Okay, now we identify what is the value for the b. So the value for the b is equal to negative 2. Okay, the value for the b is negative 2. Okay, so the next step we need to add b over 2 square. So that means we need to add negative 2 over 2 square to the both side of this equation. So we come out with this equation. Okay, so we have negative 2 over 2 equal to negative 1. So we have this equation. Okay, we have this equation. Now is to form the complete square. If you notice here, we have x squared. At the other side, we have negative 1 square. So we can combine together, come out with this complete square, x minus 1 square. And at the right hand side, we can simplify. This one becomes 1. So we have this equation. So now we move to the final step, which is to put square root at both sides. Okay, the objective is to eliminate this square. So we need to put square root at both sides. So we have x minus 1 at the left hand side, where at the right hand side we have plus minus third of 3 over 2. So now we need to solve for the unknown x. So we take 1 to the other side. So we have these two equations. Don't forget to put O at the middle. So we have the answer for these equations is equal to this solution set. The value for the x is equal to negative 0.225 or x equal to 2.225. Alright. So now we have the third method. Okay. The third method is, I think, the easiest one because we just need to use the formula. Okay, so the critical steps here is to identify all the coefficients correctly, because if you take wrong coefficients into the formula, so you come out with a wrong answer. So you need to carefully identify all the coefficients A, B, and C. So we need to consider this standard form or the general form of quadratic equation in order to correctly identify all these three coefficients. Okay, so solving quadratic equation ax squared plus bx plus c equal to 0 means that we want to find the value for the variable x. So by rearranging this equation, algebraically, actually we can come out with this equation. Okay, because the aim is to find x. So if we rearrange this equation algebraically, then we can come out with this formula. So x, which is the unknown value, equal to negative b plus minus square root of b square minus 4ac, we divide by 2 to a. So the key point here is to identify the three values a, b, and c correctly. Okay, so we consider the following equation. So from the given equation, we identify that our a is equal to 4, b equal to 9, and c equal to negative 2. Just simply insert all these three values into the formula, so we can come up with this simple form. And then finally you can take your calculator and compute the value up to 3 decimal points. So we come up with this value. So represent the answer in the set form. So this is the final answer. Okay, so same goes with this example. So you need to identify correctly all the coefficients a, b, and c. So a equal to 1, b equal to negative 1, c equal to negative 1. Okay, based on the general form of quadratic equation. So be careful with the negative sign. Okay, so put insert into the formula, so you come up with this answer. Okay. Now we move to the next topic. Next topic is about the nature of roots of a quadratic equation. Okay, nature of roots are the learning outcomes. Okay, so the nature of the roots of the quadratic equation is determined by the expressions as I shown just now. B square minus 4ac, the expressions inside the radical sign. B square minus 4ac, which is also known as discriminant. Okay, we have a special name, we call it as discriminant. There are three types of root for the quadratic equation. The first one, if the value for the b square minus 4ac is greater than 0. Greater than 0. That means, okay, the quadratic equation has two distinct real roots. Okay, distinct real roots. That means distinct. What does it mean, distinct? Okay, let's say we have the solutions x equal to a, x equal to b. So distinct means a not equal to b. Okay, so we have two distinct real roots. Okay, the next one, if the value for the b square minus 4ac equal to 0, what does it mean? That means, okay, the solutions, we have a equal to b. Okay, if the value for the b square minus 4 is equal to 0, that means the quadratic equation has two equal real roots. Okay, in the following case, that means we have a equal to b. Okay, next, if the value for the b square minus 4 is less than 0, so we back to the topic that we covered last week, which is complex number. What happens if the value inside the radical, which is the radicand, has negative sign? So it becomes complex number. The same goes with the quadratic equation. If the discriminant is less than 0, so the outcome or the solution or the roots, okay, of the complex number are two complex roots. Okay, we have the following example. Determine the nature of the roots of the following quadratic equation. So the roots mean we need to consider the value for the b square minus 4ac. Again, to answer this kind of question, you need to identify carefully the values for the constants a, b, and c. So from the given equation, we know that the a is equal to 1, our b is equal to negative 8, and our c is equal to 16. So just insert these values into the b square minus 4ac. Then we come out with the value. The value is equal to 0. So what does it mean? That means the given equation has two equal roots. Okay, so now we consider the second one. We have x squared minus 4x plus 6. Okay, as we can see here, we identify the value. We have a equal to 1, our b is equal to negative 4, and our c is equal to 6. Okay, so now we insert all these three values in this into the discriminant to come out with the value equal to 8. So 8 is less than 0. What does it mean? That means it has two complex roots. Okay, the quadratic equation has two complex roots. Okay, we move to the third one. We have 3x squared minus 9x plus 5. So as we can see here, our a is equal to 3, our b equal to negative 9, and our c is equal to 5. Okay, so insert these three values into this discriminant. So we come out with the value 21. So obviously 21 is greater than 0. So what does it mean? That means this equation has two distinct real roots. Okay, now consider the following example. Find the value of p if 2x squared minus 8x plus p equal to 0 has equal roots. So the crucial point here is the given information that the given quadratic equation has equal roots. So what does it mean? Since it has equal roots, that means the discriminant b squared minus 4ac equal to 0. Okay, that is the meaning of the given information. So we can write that b squared minus 4ac equal to 0. So from that, we identify one by one. Okay, we have our a equal to 2, our b equal to negative 8, and our c is equal to p. We insert into the discriminant, we come out with this equation. Okay, so clearly the only unknown value is p, so we can solve this equation for p and come out with this value. Okay, next, show that the quadratic equation kx squared plus 5x plus 5 equal to k has two real roots for all value of k. From the given equation, so we rearrange the equation until we get the standard form or the general form of quadratic equation. Why? Because we want to identify the value for the constants a, b, and c. So from this equation, we know that our a equal to k, our b equal to 5, and our c is equal to 5 minus k. So we insert all these three values into the discriminant. So we come out with this equation. Okay, so we simplify. So we come out with this quadratic equation, but this time the variable is k. So we solve this equation. Okay, we factorize this equation. We come out with these factors. So these two factors, because we have 2k minus 5, 2k minus 5, it becomes 2k minus 5 square. Okay, because we have square here, so it doesn't matter you replace k with any real number, it becomes always greater than or equal to 0. You can replace k with any real number, so it is always greater than or equal to 0. So what is our conclusion? So the conclusion is the equation has two real roots for any value of k. The next topic, which is about relationship between the roots with the coefficients of quadratic equations. Okay. Quadratic equation with roots alpha and beta can be written in the following form. Okay. What does it mean? Roots. What is the roots of quadratic equation? The roots mean is the value for the x. Okay, that means x equal to alpha, x equal to beta. So we can take alpha and beta to the left hand side. So we come out with x minus alpha, x minus beta. So we come out with, at the right hand side, we have 0. Okay, so x minus alpha times x minus beta equal to 0. If we expand, so we come out with this equation. Okay, we have x squared minus alpha plus beta, x plus alpha beta equal to 0. Okay, so in order to change this equation to the general form of quadratic equation, ax squared plus bx plus c, so we can write, okay, positive sign here, and we enclose the negative sign in this parenthesis. Okay, so now we have equation 1. For the equation, quadratic equation x squared plus bx plus c equal to 0, because the coefficient for the x squared is equal to a, so we can change it, becomes equal to 1 by dividing all the items in this equation by 2, or by multiplying each item in these equations by half. Okay, we multiply this one by half, this one by half, this one by, not by half, but by 1 over a. Okay, 1 over a, because we want to eliminate a, so we divide by 1 over a. So okay, we multiply this one by 1 over a. Okay, this one by 1 over a, this one also by 1 over a, then this one also by 1 over a. Okay, because at the right hand side we have a 0, so anything we multiply with 0, it's remain equal to 0. Okay, so for the ax square, we multiply with 1 over a, so it becomes x square. For the bx, we multiply with 1 over a, so we have b over a. For the c, obviously it becomes c over a. Now we consider these two equations 1 and 2. We pair one by one. Okay, so we have, okay, the red color are the equal values, and the blue color are the equal values. Okay, so what does it mean by comparing the coefficients of equation 1 and 2? So we have negative alpha plus beta equal to b over a. Okay, negative alpha plus beta equal to b over a. Okay, the red color in here. Okay, this one equal to this one. So we can take the negative sign to the other side by multiplying both sides by negative 1. So we have alpha plus beta at the left hand side, and we have negative b over a at the right hand side. So alpha plus beta equal to negative b over a. So this is the first relationship between the roots and the coefficient of the quadratic equation. Okay, again, by comparing the coefficients of equation 1 and 2, for the blue color, so we have the following. Okay, alpha times beta equal to c over a. So this is the second relationship between the roots and the coefficients of the quadratic equation. So for the first relationship, we have a special name. This relationship is known as sum of roots, because alpha and beta are roots, so we add together, so it becomes sum of roots. And then the second one, we have alpha times beta, so it is known as product of roots. Okay, so if the sum and product of the roots of a quadratic equations are known, then it is possible to write the equation as the following form. So x squared minus sum of root alpha plus beta, x plus product of root alpha times beta. Okay, so we have the following identities. Okay, that means if we have the following situations, okay, so we can replace these expressions equal to this expression, because they are equal expressions. Okay, left hand side equal to right hand side, so that means we can replace this one with this one. Okay, so previously we have alpha square plus beta square. Now it becomes, we have the sum of roots, we also have the product of roots. So later we'll see how to use the sum of roots and product of roots. Okay, other than square, we also have the following case. For the cube case, we have alpha cube minus beta cube equal to alpha minus beta. We have a parenthesis, alpha plus beta square minus alpha beta. Okay, again, we have the following, the sum of roots. We also have the product of roots. Okay, let's see. Let's consider the following example. The roots of the equation 2x squared plus 5x minus 4 equal to 0 are alpha and beta. Okay, so the following value are the roots. That is the given information. So the task is to find the values of the following. So the question asks you to find what is the value for the alpha square plus beta square, and also what is the value for the alpha minus beta square. Okay, so from the given equation, this equation, so we can identify the three constants. A equal to 2, B equal to 5, and C equal to negative 4. Okay, so using these constants, so we can compute the sum of roots and the product of roots. Okay, because the sum of roots, what is the formula? The formula is equal to negative B over A. So we have B, we have our A, so we can come out with this sum of roots. So our sum of root equal to negative 5 over over 2. So same goes with the product of roots. We have alpha and beta equal to equal to c over a. Okay, equal to c over a. So we have our c equal to -4, our a equal to 2. So we come out with this value as the product of roots. So now we have the sum of roots, and we also have the product of roots. Okay, how to use these two values? Okay, we start the first one. The task is to find what is the value for this one. So back to the previous slides. Okay, we have the identities. What is the identities for the alpha square plus beta square? The identity is equal to alpha plus beta square minus 2 alpha beta. Okay, so now it's become easier for us to solve this equation because we already have these two values. We have the sum of roots. We also have the product of roots. So just replace the value into the equation, come out with this equation. So we simplify this expression, we come out with this equation, and finally we provide this as the final answer. Okay, move to the second one. We have alpha minus beta square. So alpha minus beta square, that means we can expand this equation. We have alpha minus beta times alpha minus beta. We expand, so we come up with this equation. In this equation, we can rearrange. Okay, we can put together alpha square and beta square like this, and we put together at the end of this equation we have -2 alpha beta. So for the alpha square plus beta square, the value is already, okay, is the outcome from this equation, from this question. Okay, we have alpha square plus beta square, so we just simply take this value. Okay, take this value, which is equal to 41 over 4. Okay, 41 over 4, and then minus 2 the product of roots. Okay, we have the product of roots alpha beta equal to -2. Okay, insert that value to this equation. So we can solve this equation, we can simplify until we come out with this simplest fraction as the answer. Okay,